Unit 1, page 6 notes, trends in relationships. So now that we understand how to graph, how do we understand relationships between the two variables in a graph? Well, let's talk about how we use data. So things that we can do once we have data collected in science is determine relationships, find trends, draw conclusions based on what we've hypothesized before the experiment. We can make predictions for different experiments in the future and create new hypotheses and experiments based on the data. What is a relationship? Well, a relationship compares two or more factors. Most of the time we're going to have two variables that we'll be comparing how they relate to each other, if at all. First, you have to say, do they even relate? If one factor doesn't affect another factor, like, let's say, your hair color affects how hungry you are, then there's no relationship between those two variables. Sometimes there's a strong relationship and sometimes not so much. If both increase or decrease, it's called a linear relationship. They both do the same thing. If one increases while another decreases, it's called an inverse relationship. So let's check. Which kind of relationship does this look like? As the age increases of the child, does the height of the child also increase? Yes. This is called a linear relationship. What kind of relationship is this? As the time goes on, in terms of hours spent watching TV, does the number of homework assignments completed increase or decrease? It looks like it decreases. So as hours increase, homework assignments decrease. That would be called an inverse relationship. Some relationships are a little more complex. The first graph that you have in your notes has the question at the top that says, what is the optimum pH, which measures how acidic something is, for tadpole development? Now, what does the word optimum mean? Optimal means the best. Optimum is the best pH for tadpole development. Okay, so let's find out. Let's look at our graph. Where is pH of water? And it's not listed on here, but if you look in your notes, pH is on your x-axis, okay? And it goes from about 3.5 all the way to 8.5 on your graph. Numbers of tadpoles can be found in the y, and that goes from 0 all the way to 80. Now, what is the optimum, the best pH for tadpole development? What would we be looking for here? Hopefully you figured out that we should be looking for the highest point on the graph. The one where the number of tadpoles will be the most to have an optimum pH for tadpole development. Hopefully you found this point to be the highest. Now what we have to do to get the answer is drag our finger down here and read the pH. What is the pH at that point? It's 6.5. So that would be the optimum pH, 6.5. On that same graph, which is copied again underneath with a different question, between what two pH readings is there the greatest change in tadpole number? So if we're looking at change, we've got to compare. And we're going to compare the different pH readings. So at 5.5, there's about 20. At 6, there's 40. So the difference here, hopefully you already know, is 20 tadpoles. All right, so that's a lot, but maybe not that much. If we look at the graph, this looks like a big jump. So let's look. 6, there's 40. If we drag our finger over here, 40 tadpoles. At 6.5, how many tadpoles are there? Hopefully you said 80. So from 40 to 80, that's a 40 tadpole jump. So that looks like the most. And if we count the rest of these, this is 10, 5, and then another 15. Okay, so this is the largest jump between 6 and 6.5. And on your graphs, you can just circle those parts so you know the answer. On the next page, how many tadpoles would you expect to find in water with a pH reading of 5.5? So what do we need to do here? Well, we need to kind of predict where the data would be if it were represented on a piece that's not shown here. So we see a pH of 5 and there's no data here. There's no point anywhere. So where do you think the point would be? Would it be way up here? Or even here? Or here? If you look at the trend, this is a line going down. So most likely it would continue that direction downward. So the number of tadpoles might be around 10 or even less than that, depending on your guess. But it would be acceptable to have anywhere from 0 all the way to 15. Now let's practice interpreting data. So you have 4 different pictures here, and I'm going to give you 3 different scenarios. I'm going to give you A, B, and C. And I want you to match the graph with the story. And you can either draw a line or write the letter next to the picture. So letter A, I had just left home when I realized I had forgotten my books, so I went back to pick them up. Which graph matches that story? And your 2 variables here are time, that's on the x, okay, this is further along in time, and this is distance, with the higher point being further distance from home. Hopefully you guessed 4. So if you leave home, you're starting at 0, and you realize you had forgotten your books, so you have to go back. So you had left, you're some distance away, then you go back home, so you go back to 0, and then you leave again. So notice it goes up, back to 0, you're at 0, and then it goes out. B, I started out calmly but sped up when I realized I was going to be late. So you're starting out calmly, meaning you're probably walking pretty slow. So if you're looking for a graph that you're going a little bit slow, and then you start to speed up, so the graph, the line will increase as time progresses. So hopefully you got number 1 as the match for B. And then last, C, things went fine until I had a flat tire. Hopefully you guessed 2. So everything was going along smoothly, and then notice this distance, that's where the flat tire was. You're some distance from home, and then you continue again after you fix it.
3 towers with